Hello, everyone, and welcome to the Rivery Change Data Capture webinar. Before we get started, I want to go over a few housekeeping items. So first, this webinar will be recorded, and you will receive an email with it tomorrow. So if you want that for replay or to share with colleagues, please be sure to look out for that. Next item, all attendees are muted. So if you have any questions at any time throughout the webinar, please put them in the Q&A tab, which can be found at the top right of your screen, and we'll do our best to get those answered for you at the Q&A session. Lastly, we've just shared an ebook on CDC, which covers the business case for change data capture in more detail. You can access this via the handout tab at the top right of your screen, and this will be available to view or to download throughout the duration of the webinar. Now, with that, I want to pass it over to Rivery co-founder and lead architect, Alon Resnick, to kick off today's presentation.
Hello, everybody. How are you? Hi, let's start. Okay, little about me. Hi, I'm Alon. I'm a lead architect and a co-founder in Rivery. In the last 11 years, I had a lot of data projects, especially in big companies. I was a data engineer. In the last 2 years, I'm the architect of the entire solution in Rivery. I'm very excited to show you today and present about the CDC solution we have. And let's start for our agenda. Our agenda today, we start with a quick explanation about Rivery. In the second point, we'll talk on what is database migration, what are the pain points in that, and what are the methods for doing this today, and how change data capture solves some of the issues we encountered so far in our project. And in the third point, we'll make a quick overview on Rivery Architecture of the CDC, and then what are the advantages and what are our methods in this kind of solution. And in the end, we'll make a live demo on the product to show you how to initiate CDC process in a couple of minutes using Rivery. And in the end, as Alex said, we have a Q&A session. A little bit about Rivery. We are a fully managed platform that handles data integration, data management, data orchestration, automation in one-stop shop. Our platform provides quickly ingestion of any source in auto-scalable way in one simple SaaS platform. Rivery provides today cloud nativity, means that you can be used Rivery, and we are supported and partners of every four main warehouses in the market. Means BigQuery, Redshift, Snowflake, and Amazon Azure. Currently we have offices in Tel Aviv, in New York City, and soon in London. So for today's subject, what is the goal? Let's start with what is the goal of database migration. What is the main problem? When we are running on database migration projects, we want that the data of the database and the metadata will be reflected almost simultaneously into the data warehouse. One of the most big headaches in database migration is that the analytics processes, means like BI processes, should run today with synchronization with the other operational processes that we have in organizations. Means that if we have some application that writes things to the database, which is operational, or any other sources that write and manage the database, that all the application and all the organization use. Most of the data projects today can be done just using what we call nightly. As it runs in the past, you mean that you can't run it as just 4, 5, 6 hours at night when everybody is asleep, and then you come in the morning, because the database is constantly changing by the application, by the users, by a lot of data that is coming in, and you have to handle it in very, very short time. Therefore, the analytics reports and data warehouse must be synced constantly with the source operational database. That's the main thing, is the reflect the changes in the implementation of your products. Okay, so in the past, or actually today also, we have 4 migrate data changes method that we can use. We use 3 of them in Rivery, and the 4th one, actually, we don't recommend to use it. Okay, the first one is what we call this timestamp solution. It means that you using a managing timestamp on every table you want to pull data from and push it to the data warehouse. In most cases, there are at least last update or date modified columns that need to be maintained in the table. The biggest headache here is actually maintain it and to manage the application that using each database table to insert, update values for those columns. Moreover, in order to make sure we can pull the data using these columns, we need mostly to create indexes above them. Something that in some cases can be made because don't have permission, or database is too big, or something something just blocks you to do it on database because the application, another application use it. And this is also can harm our inserting and updating performance to the tables. The second approach is getting the what calls table differencing. It means that we are getting the entire table differentiating using merge. We can get the entire table every time and then run it and merging to the target. But that's nice when you have a very quick and small and nice toy database. But in the end, if you have a very big database with a lot of rows, petabytes, terabytes, even hundreds of gigabytes, and you have a lot of tables, that's become a very, very big headache, especially in performance. And of course, this can be harm your performance in the database, because getting the entire table again, every time you want to load it in very big tables just can block your database. The third method, it's the triggered one. It means that every change is triggered and updates a new last update column. We can use trigger and update and insert new values in the first time, like as in the first timestamp columns. However, this is something that we need to set for every table independently in the source in the database, and also need to be maintained. That every change about the trigger or about the columns that the triggers triggered, you have to maintain it. And more than that, this is something that is very, very waste of performance. That it takes a lot of performance, especially in inserts, and you don't want it, because this is something that is very, very, very not recommended to do on the tables. The fourth method, this is what we're going to talk today, is the log-based. This is the CDC, change data capture. Instead of pulling tables, let's pull the entire database from some log. Most of the databases, the commercial database in the market, just write log into, just write rows into a log. For mostly for replication operational needs, but we can get into this log and reverse engineer it to recover also the data and also the metadata of the tables. Every change is just set in the log, pushed to the log, and then we can get it, recover it, reverse engineer it, and then make the entire table and the entire changes in the other side. That means that we don't need any SQL to do it. Nothing's actually run on the database itself. And this is more just one-time kinds of DevOps operation, and that's it, actually. Okay, so change data capture, the log-based, as mentioned, is a method that provides running continuously and on the stream of the database log, pull data and metadata changes and sync them in stream or in batch to data warehouses. You just trim the log to your needs and then push all the changes to the target. Okay, so what are the pros and what are the cons of the change data capture? The most important thing here, I think, that is we can stream only changes, means that you don't have to concerns, first of all, the database size and the table size you are using. We don't use SQL, so you're not using actually the CPU or the compute power of the database itself, and you just read log. So you can get the data very fast and also the metadata very fast. It's all one touch, okay? You are sync in one touch to the cloud. It's all centralistic. The entire database is writing rows to the log itself. And some very cool thing that you can keep deletes, that every deleted row is written to the log, so you can get what also deleted. If you go to the table and select it, you can get it because you only see some snapshots. So here you can see in point of time, like all the deletes rows that were deleted from the database. Okay, so what are the cons? I think the main con here is that you need some kind of more skills than just being someone who knows SQL. You know, you should know how to maintain some kind of options and parameters in the database configuration itself. In most cases, people now use some cloud databases like RDS or SQL or SQL in Google Cloud platform, which is in most cases configured automatically. But if you don't have one of them, you have to maintain by yourself, especially maintain the disk and maintain the storage, because again, this is a log which is written on the disk, and you have to do that in order to maintain that the database won't just database disk won't just be full. Okay, let's go quick to our architecture. Okay, I will use drawing in here in a minute. I'm sorry. Okay, so let's say that our architecture of CDC of change data capture is something that is based on two phases. One is the old streaming phase, which is this one, okay? And the other one is the other phase that just pushed the data that was streamed to the data warehouse. In the stream phase, we are constantly get the data from the logs. Every row that is written here, in the end, in a minute or two, should be in the file zone. The file zone is actually cloud storages like S3, Google Cloud Storage, or Azure Blob Storage. And every row that is written in the client database log will get into our Kafka. We have a centralistic Kafka. In a minute, I will say what is Kafka for the ones here that doesn't know what is it. And after that, we have consumers that get the data from the Kafka and push it to the file zone. Kafka, as mentioned, this is a very high rate, massively performant and distributed system. It calls a pub sub, means that it can get and publish and push messages in very, very high rates. So if the log is written here in very high rate, it means that the producer is just getting the data every message. Just get a message in bunch, push it to the Kafka. The Kafka knows how to handle it in very high rates. And then the consumers get the data by triggered from the Kafka and consume the data, consume the message, the log messages, and push it on the file zone. The second phase of the process, as we do it today, is actually very. I think it's even more interesting than the first phase, because the first phase is just it has a lot of headaches, and the architecture here is very complicated. But in the end, you get a very a big raw data in the file zone. So you need to know how to handle dedups, for example, because every row can be written more than once to the log, because every update, every change, every delete, every insert, again is written to the log. And let's say a row can be inserted and then update and then delete, and then another insert with the same key. So you have to manage the last updated row here, and know what is the right row to push to data warehouse in order to have the same structure of the client database. So in this phase, this is actually what we're doing in Rivery now. We are handling all the dedup, the merging of the database, the keys, and also the metadata changes. Means that we know what are the metadata has changed here, but in the end we need to push the metadata changes to the data warehouse. Okay, let's move to a quick live demo. Okay, we'll share my screen. I've already made a quick river that is actually getting data from log. The log is written on Postgres. We are using what calls DVD rental Postgres database. This is actually official example of Postgres. And what we're doing now is actually getting data from the log in constant, like in continuous way, from the log in Postgres to the tables. When this checkbox is on, means that the log is streamed. Okay, every change in the log now, in the what calls write ahead log in Postgres, is written to our S3, and from them we can choose in what how do we schedule the push of the data to the target. The two things I just had to do here is get my connection. Just I set the connection to the Postgres and click on log base. This is the source step. In the target step, I had to choose my target connection, which is Snowflake. That's my data warehouse now. And where do I load? I can load to any database schema, and also add some table prefixes to the every table that is written from the log. And another cool feature that we have is actually keep also the raw log data in the database for every table that the log is written to. Means that you can also reverse engineer and get the rows from the log itself in the data warehouse, and then create another tables from this log. Every table that will push and that we get in from the log we'll have also, if I check it here, we'll have also a log table. In the mapping step, I chose 5 tables. Again, we are using DVD rental, so I chose film, category, actors, inventory, and customer. Okay. And what I did, just enable the log. This is something that take some 20 seconds, stuff like that, to enable all the things, to connect and enable the log. So I won't do it now, but you have to believe me, this is on. And let's do some operations on the database itself. So I have here three commands. One inserts data to the inventory table. One deletes some ID from the actors table. Let's say it will be 4. And one is updating the inventory table again with specific inventory ID. So I'll do it. I'm sorry. I'll do it this one, so it will be connected. I run now the insert. As you can see, I've inserted 28,000 new rows to the table. Okay. I run the delete. So I just deleted the actor ID where actor ID is 4. Okay. And now we can see You know what? I will keep the inventory update to the other phase I want to show you. And this is my snowflake. Okay, the snowflake here. I have again, I have an inventory table. I have push data into it, so it already exists. But in the end, I can show you here. Oh, sorry. That this is the inventory table with all the log table, the new log table. When I will run now the river, every change that was written to the log will be written will be pushed to the target. If there is nothing, you will get this warning about there's nothing to fetch from the log. But in this case, we have two tables. One is the actor one, which I just deleted one word there, and the inventory I just inserted new rows into it. Let's keep it. Let's check if it when it will be complete. It should be complete in a minute or so. Okay, the actor is already completed. Now the inventory, meanwhile, okay, it's all completed. So I went again to the snowflake, and I can show you now that I have pre-existing deleted rows, and also actor number 4 that was deleted, and now is marked as deleted as true. Means that you have here in the snowflake something you don't have now in the source database, but you can see that was deleted, and this is actually the time it was deleted from the source. Another thing I can show you is the new rows I've just pushed automatically to Snowflake in just 2 minutes, less than 2 minutes.
All right, thank you, Alon. We're now going to open it up for questions and answers. We've got some questions here in the queue, but again, if anyone does have additional questions about Rivery or change data capture capabilities, the Q&A panel is still open, so feel free to send those through at any time. And if you'd like to learn more about the CDC or the business case for this product upgrade, the ebook is still available in the Handouts tab at the top right of your screen. So I'm going to start here with the first question, which is, does Rivery require an agent program installed on the client's database server? What database server types are supported?
Yeah. Okay. So thank you. First of all, thank you for all the questions. For the first question, nothing has need to be installed in the client database server. Everything is installed in our side. Means that because Rivery is a SaaS platform, that means that we know how to get into the database. Push the data from the log, which is just need to be enabled in the database server, and that's it. Nothing need to be installed. And we also, for now, we are supporting MS SQL, SQL Server, Postgres and MySQL, and in the near future also Oracle database.
Thank you for that, Alon. So the next question here is, can you elaborate on the Kafka service you use here? Do you use Kafka to connect KSQL syntax and then wraps them in with more capabilities?
Okay, so again, for the Kafka, we don't need to. We don't use any KSQL. Of course, it's something that we are think about to use any more abilities in our product. But for now, we have some kind of Kafka Connect that go from both sides. The producer is Kafka Connect that goes self-implemented, that goes to the database and push the data to the topic in Kafka, and from the other side, we are getting the consumer that gets the also Kafka Connect that go to the topic and then push it to the file zone.
Great. Now, the next question is CDC available now?
Yes, of course. This is my live demo was on the production, so you can go in and dig in.
Okay, and the next question we have here is, this method would use a Snowflake warehouse. Is there an option to drop to S3 and then let Snowpipe continue with the ingestion to audit the tables?
Yes, it is. You can push the data to only S3 and then use Snowpipe. However, I think this is less recommended. First of all, because the data that comes from the log is actually a raw data for all the events in the database, and then you need to know how to handle it. I think as I mentioned in the presentation, I think this is the main headache actually in pushing data into data warehouse today from the CDC. Because getting the data from the CDC to the files on this, we use Kafka and use more pre-built architecture. But in the end, the best solution you have to do in the Snowflake or in every warehouse you want is to know what is the best practice to use the dedups and merge and compare keys and more than that. I mentioned that we also are providing a metadata sync, that every data type or every columns that dropped or added to the table in the source will be also pushed and synced in the Snowflake. So getting the data to the Snowflake, that's nice, but in the end you have to also maintain and manage the tables as they are in the source.
Great, and quite a few questions here today, so
Yeah.
thank you everyone for asking them. Following up on the Kafka question, what about joins between tables? Does Rivery support them regardless of CDC?
You mean in the process? Actually, our main approach calls ELT means that we are supporting, of course, pushing the data to somewhat calls ODS or mirror tables as they are in the source. We think that the best approach is not making the entire mechanism of join or any intelligence in the ingestion phase, but do it after that. And for that, we are using we have what calls the logic river in the system that you can manage and make joins, and of course put all your intelligence and the logics upon the table that you just pushed from the database. So in order to use the power of these data warehouses, and they are very powerful, we suggest to push the data in constant or batch to the and stream or batch to the data warehouse, and then use data warehouse to make all the joins and all the intelligence on it.
All right, so we have time for a few more questions here. Next one I have is, how do you manage data type changes in the source and in the targets?
Okay, actually we are thinking about we thought about very much about how to do that, because in some cases you have to implement some kind of synchronization between 3 or more types of databases to 4 or in the near future more type of data warehouses, and everyone is talking differently. So in the end, what we're doing now is actually implementing some kind of the winner takes it all, or the most wide data type as the winner in the data warehouse side. So if something has been changed from, let's say, from a string to a varchar to an integer in the source, and first of all, it was pushed to data warehouse as a string. Now it will be stay a string data warehouse, because we think we want, of course, keep the history data that was already pushed to the data warehouse, and also we want to keep it synced as most, but in the end we don't want to get the other processes that use this table to change their data types and in all of the process. So we know how to implement and how to convert the best data type that will fit to the data warehouse.
Thank you, Alon. And next question here. So what happens if a column is dropped from the source itself?
It will be kept as column in the target. Means that if you have a column that was dropped in the source and you have it in the data warehouse, we don't want to drop it from the warehouse again, because there are a lot of processes that use it, and in the end there are reports also that use it. So what we're going to do is just push null values to these columns, and we know how to handle that in the source side.
Thank you. Next question here. Can CDC handle change to table shape? For example, an added column in the source table.
Yes, we know how to sync edit, dropped data type changes from the source to the target. Means if you add, in this example, column to the source table, it will be added to the target.
Thank you. And let's see, next question here. What happens if a column name has been modified or not deleted?
Column name. Okay, so now we're getting a new name. So we are actually creating a new column in the data warehouse, and the old name will be in the null values, because we need to know how to fetch the names from the new from the old to the new. So we want to again to make the data warehouse table as wide as we can as the history of the source. So we are now creating a new column in the data warehouse in this case.
All right, let's see. Next question here. How do you sync different tables at once?
Actually, because the log is written from the entire database, we know to sync lots of tables. Like we just need the definition of what tables we want to sync. So we're just getting the log, and then we know how to split it to tables in the Kafka, and then we know how to go from each table and get the right data for each table from the Kafka topic. So in this case, we split the entire database tables as chosen in the river to topics, and from them go it just another ingestion source.
Thank you, Alon. So I believe that concludes what we have from a Q&A standpoint today. If anyone does still have questions that they'd like to ask, please email us at contact@rivery.io, where Rivery Expert can help you and also answer any pricing model questions based on your specific use case. Additionally, look out for the webinar recording email tomorrow. And with that, I'd like to thank everyone for taking the time to join us today. And thank you again to Alon for a great presentation. Take care.